Hey, good afternoon, rockhounds and rockheads. Laura from Rock Your World coming right at you with another Tales from My Yard. Anyways, I promised you more videos, and so in this one, I guess I'll talk a little bit more about agates. Alright, so what are agates? Agates are made of quartz. What is quartz? Silicon dioxide. Why doesn't this look like a quartz crystal that you normally see? Well, because these quartz crystals are so teeny tiny that you cannot see them individually with your eyes. You need a microscope and even then a powerful electron microscope, and they still might not look like quartz crystals that you recognize. Quartz likes to form in a couple different ways. One of them are the quartz crystals that we know of, and that's a monomeric way. That's kind of a big scientific word, but the way that quartz forms when we make agates is more of a polymeric way. And I don't know if you remember anything from high school science class, but polymers, plastic is also a polymer. So we can kind of equate agates to earth plastic. And it makes a gooey mess of things often, just like plastic will. So I have a bunch of different varieties of agates here. I was going to go over them. Some found on the beach, some found in the desert. Some you might go, that's an agate, what? So this one I'm holding is a thunder egg from probably Richardson's Ranch. And as you can see by the translucent band of material, we've got an agate band. Now, how do we know that it's an agate? One, agates are translucent. They're either translucent because the crystals don't get in the way of the light, and also other substances don't get in the way of the light. And so that's one of the ways that we can tell something's an agate. The other way we can tell it's an agate is it has what's called a conchoidal fracture. So a conchoidal fracture, the root word for that is conch, or shell, and it's a shell-like fracture. And as you can see on the edge here, you've got what looks like a seashell. And so that breakage there is the stone's cleavage. Shut up, butthead. Cleavage. Anyways, these are not professional videos. These are me just sitting in my yard talking to you about rocks. So with that cleavage, that's another giant indicator. So translucent, conchoidal fracture. The other thing is that agates are harder than steel. So if you have a pocket knife, you're going to notice that you can't scratch this thing. You're just going to break your pocket knife. So I'm going to move on. So this is a thunder egg, by the way. We can tell from the outside. It's got a lot of the pearlite still on the outside, and then your brown rhyolite core, and then your agate interior that glows in the sunlight. All right, next agate. So these you're probably more familiar with. These are our beach agates. We have a regular clear one with some carnelian banding. We have some of our famous blue blacks here on the Central Oregon coast. This one's got a nice carnelian to it. And you hear me using these terms agate, which we're getting familiar with, silicon dioxide, teeny tiny crystals, translucent, can see through it, very harder than steel, conchoidal fracture. So when I talk about a carnelian agate, carnelian is our normal everyday agate, but it's colored by iron oxides. So, and that can show up anywhere from, big trucks. We have so many big trucks in my neighborhood, Anyways, from iron oxides, so anywhere from yellow to red. So yellow, orange, red, gonna blame iron oxides in most instances. And in also most instances, those iron oxides are an afterthought. So they come up after the agate has actually been freed from its host material and reburied in an iron-rich soil. The more porous areas in the agate will uptake those iron oxides and those cool colors. Sometimes there's iron oxides in the stone as it's formed, and it takes the iron oxidizing in order for the color to come up. So it actually takes water and oxygen to get in there and create the iron oxides. And all that flapping you hear are our neighborhood pet crows. Let's see if I can catch him without flowing away. There. So anyways, back to rocks. So these are beach agates. The blue blacks, that's going to come from manganese oxide. And once again, agates are porous, and that's something that's usually taken up after the agate is formed. But those metals can be in the silicon dioxide when they settle down and become a rock, and later water can oxidize those and bring out the colors. Does that make sense? The metal has to either be trapped in the agate when it's formed, or it gets sucked up into the agate after the agate's formed in order to give you the color. Okay. Now blue agates are different. I don't have any good examples here, but a lot of our blue agates like the sky blue ones when you think of an Ellensburg blue, come actually from the same reaction that creates blue in the sky, and it's how the light reflects back out of the stone. And that doesn't have much to do anything with any kind of particular metal in the stone, but how the chalcedony, which is a type of quartz, and other quartzes form within the stone. I'm not going to get too scientific. It can get really confusing. Here's a big agate. I just wanted to show it to you. It's another one where you can really see those conchoidal fractures. Big beach agate. All right, I'm going to toss that one. So I have some other agates here, and these ones are from the desert, and they look a little more rough than the ones that we're used to from the beach. This is a full amygdal, and an amygdal is just a gas bubble in a volcanic flow, a lava flow. And what happens is those lava bubbles, then meteoric water or hot spring water will bring, come on, focus. We'll bring silica into the pocket and leave it there. If you've ever stirred too much sugar into your iced tea, you know that it will fall out and make a slick at the bottom of your iced tea. And that's essentially the basics of how agates form. There just gets to be too much silica to be held in solution, and it ends up depositing. And then once a little silica gets in there, it essentially nucleates, and it polymerizes, and it wants to glob together, and so by nature it will glob and fill the cavity as more and more fills it in. It just takes a little to start. All right, there's that. So then we have something like a plume agate, where these are filled in hot springs. And you have opal on the outside with agate on the inside. And what's the difference between agate and opal? They're both made from silicon dioxide. Opal just has no crystal structure, and agate and quartz does have a crystal structure. And so that's why you can see the opal is all cracked and crazed, is that it doesn't survive very well. It's very unstable. It also has a large water content, but so does chalcedony. All right, and once again, chalcedony is one of the main ingredients in our agate. It's a type of quartz, and it has water in it. This is another type of agate, and this was found up in the Ochiko Mountains in a rhyolite dome. This is pretty pure chalcedony, but people would also call it an agate. Sometimes there's banding in it. Some people will tell you that a stone has to have banding or a pattern in it in order to be called an agate. Otherwise, it's just chalcedony, but that's something rockhounds argue about. Scientists just call this cryptocrystalline quartz, and then they observe the texture, which this one doesn't have any particular textures to it other than just clear chalcedony. We're going to talk about textures because I'm going to show you this one last weird agate, and then I'm going to get out of my yard because the sun is setting and it's getting cold again. Just another example of a desert agate, rough, a little bit carnelian, but just in the cracks you can see. All right, so this is an agate, and you're like, what? How is that an agate? That looks like jasper, which jasper is the same agate material, and it's the same material as agate, but it has other stuff in it that makes it so that you can't see through it. But this is not a jasper. This is still an agate. And you're like, tell me how. Well, let me spit on this rock real quick. Yep, I did that. So this was found on the beach, and you can see out by all the white that that's going to be an indicator that there's agate material in there. Essentially, agates have so much silica in them that they're weeping the silica back out as opal on the surface, and salt helps that process. And so these are actually opal-y bands on the outside indicating agate on the inside. And when we turn it over, spit, let me get you in the sun, you can see that there is a moss pattern to it. Looks like there's a red moss. And so that is also a kind of agate. It's called a biological texture. It's that same thing we're talking about with plumes. And that is extremophiles and thermophiles were in this cavity creating different proteins that created patterns that when the silica and other particulates got caught in them, created these colors and patterns as it got essentially stuck in the earth's snot, for technical terms. So essentially a moss agate or a plume agate or a flame agate, these are all formed in hot springs, and there's different microbial mats that form in different temperatures with different metal contents and different chemistries. And each one actually helps us form these patterns or textures, or what they're called, biological textures, in these rocks that we like to collect. So, hope you enjoy that video. It's pushing 10 minutes. I'm going to go back inside. This is Laura from Rock Your World. When you're out there rock hounding, stay safe, stay dry, use your heads. Tales from my yard. What are agates is now coming to an end. Have a happy Black Friday. Laura from Rock Your World, over and out.